Okay, let's get started. In this video, I'm going to introduce you to functions. Once you learn about them, you won't be able to stop using them. My shortcut functions. Break that. 2 times speed.
In this video, I'm going to introduce you to functions. Once you learn about them, you won't be able to stop using them. I sure can't. Functions aren't entirely new for you, actually. You've already used them. Type, for example, is a function that returns the type of a value. But what is a function? Simply put, a function is you can call functions instead of having to write code. Suppose you have the list containing only the heights of your family, fam, and say that you want to get the maximum value in this list. Instead of writing your own piece of Python code that goes through the list and finds the highest value, you can also use Python's max function. This is one of Python's built-in functions, just like type. We simply pass fam to max inside parentheses. The output makes sense, 1.89, the highest number in the list. Max worked kind of like a black box here. You passed it a list, then the implementation of max that you don't know did its magic and produced an output. How max actually did this is not important to you. It just does what it's supposed to, and you didn't have to write your own code, which made your life easier. Of course, it's possible to also assign the result of a function call to a new variable, like here. Now, tallest is just like any other variable. You can use it to continue your fancy calculations. Another one of these built-in functions is round. It takes 2 inputs. First, a number you want to round, and second, the precision with which to round, which is how many digits after the decimal points you want to keep. Say you want to round 1.68 to 1 decimal place. The first input is 1.68, the second input is 1. You separate the inputs with a comma. But wait, there's more. It's perfectly possible to call the round function with only one input, like this. This time, Python figured out that you didn't specify the second input and automatically chooses to round the number to the closest integer. To understand why both approaches work, let's open up the documentation. You can do this with yet another function, help, like this. It appears that round takes 2 inputs. In Python, these inputs, also called arguments, have names, number and n digits. When you call the function round with these 2 inputs, Python matches the inputs to their arguments. Number is set to 1.68 and n digits is set to 1. Next, the round function does its calculations with number and n digits as if they are Python variables in a script. We don't know exactly what code Python executes. What is important though, is that the function produces an output, namely the number 1.68 rounded to 1 decimal place. If you call the function round with only one input, Python again tries to match the inputs to the arguments. There's no input to match to the n digits argument though. Luckily, the internal machinery of the round function knows how to handle this. When n digits is not specified, the function simply rounds to the closest integer and returns that integer. That's why we got the number 2. In other words, n digits is an optional argument. This tells us that you can call round in this form, as well as in this one. By now, you have an idea about how to use max and round, but how could you know that a function such as round exists in Python in the first place? Well, this is something you'll learn with time. Whenever you're doing a rather standard task in Python, you can be pretty sure that there's already a function that can do this for you. In that case, you should definitely use it. Just do a quick internet search and you'll find the function you need with a nice usage example. And there is, of course, DataCamp, where you'll also learn about powerful functions and how to use them. Get straight to it in the interactive exercises, and I'll see you back here soon.
Okay. Oh crap. What? Out of the box, Python offers a bunch of built-in functions to make your life as data scientists easier. You already know 2 functions, print, type. You also use string, int, boolean, float to switch between data types. Calling a function is easy. To get type 3.0, store the output as a new row or result. You can get the following. General recipe for calling functions and saving the result to is yes. Use print in combination with type to print out the type of var1. Okay, print type var1. Print out the length of var1. Use the length function len to get the length. Print the length of var1. This is gonna get mixed up with my. You know, it's fine. Just focus on Python for now. Use int to convert var2 to an integer. Store the output as out2 equals int var2. No way, wait, what's going on? logged in. Continue introduction to Python. Got it. Alright. Sure, I need to do that again. Print type var1 print len var2 out2 equals int var2. Print. Oh no, it's var1. Oh, I'm so dumb. Alright. Maybe you already know the name of a Python function, but you still have to figure out how to use it. Ironically, you have to ask for information about a function with another function, help. In Python specifically, you can also use the question mark before the function name to get help on the Mac. Really? Help. Wait, down. How do I go down again? Help on built-in. Oh wow, this Python's way better than Java. What the heck? Literally helps you. For PAL. Question mark PAL. Power base exp mod equals none. What? Equivalent to base with 2 arguments. Base with 3 arguments. Able to use a more efficient algorithm. Power takes 3 arguments. If you don't specify mod, the function will return the error. Base, exp mod, base and exit are required arguments, mod is an optional argument. I assume this is the answer, because it says none. Okay, that's a lot of... In the previous exercise, you identified optional arguments by viewing the documentation with help. You do now apply this behavior to change the behavior of sorted function. Look at the document sorted. Unsorted. How do I... Come on! This is signature... none reverse false. Custom key function can be supplied to custom sort, and the reverse flag can be set to request the result in descending order. P equals none means that if you specify key argument, it will be none. If you don't specify the reverse argument, it will be false by default. And just say you only specify iterable, reverse, and not key. The first input you pass sorted will be matched to iterable. What is iterable? What about the second input? To tell Python you want to specify reverse without changing anything about key, you can use equals to assign a new value. Okay, full equals first plus second. right? Is this how you do it? I don't even remember at this point. Sort full and descending or it is iterable. An object capable of returning its members one at a time. Oh, so like a list. Oh, it literally just says excuse me. Alrighty. Use plus to merge contents first. Yep. Cool. Sorted. On the full. So the reverse argument reads C. What? What does reverse mean? I'll just do it. I'll just full underscore sorted equals let's sort the full iterable thingamabob, and then we call reverse true, and we print out full underscore sorted. Okay. Oh, there's a problem. Reverse. Wait, is that not how you do it? Do I just write true? What is key? Let me guess. Capital. Frickin' capital. Okay, methods.
Built-in functions are only one part of the Python story. You already know about functions such as max to get the maximum of a list, len to get the length of a list or a string, and so on. But what about other basic things such as getting the index of a specific element in the list or reversing a list? You can look for built-in functions that do this, but you won't find them. In the past exercises, you've already created a bunch of variables. Among other Python types, you've created strings, floats, and lists, like the ones you see here. Each one of these values or data structures are so-called Python objects. This string is an object, this float is an object, but this list is also, you got it, an object. These objects have a specific type that you already know: string, float, and list. And of course they represent the values you gave them, such as lists, 1.73, and an entire list. But in addition to this, Python objects also come with a bunch of so-called methods. You can think of methods as functions that belong to Python objects. A Python object of type string has methods such as capitalize and replace, but also objects of type float and list have specific methods depending on the type. Enough for the theory now. Let's try to use a method. Suppose you want to get the index of the string mum in the fam list. Fam is a Python object with the type list and has a method named index. To call the method, you use the dot notation like this. The only input is the string mum, the element you want to get the index for. Python returns 4, which indeed is the index of the string mum. I called the index method on the fam list here, and the output was 4. Similarly, I can use the count method on the fam list to count the number of times 1.73 occurs in the list. Python gives me 1, which makes sense because only Liz is 1.73 meters tall. But lists are not the only Python objects that have associated methods. Also floats, integers, booleans, and strings are Python objects that have specific methods associated with them. Take the variable sister, for example, that represents a string. You can call the method capitalize on sister without any inputs. It returns a string where the first letter is capitalized now. Or what if you wanted to replace some parts of the string with other parts? No problem. Just call the method replace on sister with 2 appropriate inputs. In the output, Z is replaced with SA. To be absolutely clear, in Python, everything is an object, and each object has specified methods associated. Depending on the type of the object, list, string, float, whatever, the available methods are different. A string object, like sister, has a replace method, but a list like fam doesn't have this, as you can see from this error. Objects of different types can have methods with the same name. Take the index method. It's available for both strings and lists. If you call it on a string, you get the index of the letters in the string. If you call it on a list, you get the index of the element in the list. This means that, depending on the type of the object, the methods behave differently. Before I unleash you on some exercises on methods, there's one more thing I want to tell you. Some methods can change the objects they're called on. Let's retake the fam list and call the append method on it. As the input, we pass a string we want to add to the list. Python doesn't generate an output, but if we check the fam list again, we see that it has been extended with the string me. Let's do this again, this time to add my height to the list. Again, the fam list was extended. This is pretty cool because you can write very concise code to update your data structures on the fly, but it can also be pretty dangerous. Some method calls don't change the object they're called on, while others do. So watch out. Let's take a step back here and summarize this. You have Python functions like type, max, and round that you can call like this. There are also methods which are functions that are specific to Python objects. Depending on the type of the Python object you're dealing with, you'll be able to use different methods and they behave differently. You can call methods on the objects with the dot notation, like this, for example. There's much more to tell about Python objects, methods, and how Python works internally. But for now, let's stick to what I've talked about here. It's time to get to some exercises and add methods to your ever-growing skill set. Let's get you coding again.
Oh, man. Strings come with a bunch of methods. Follow the instructions. Follow the instructions closely to discover some of them. If you wanna, you can help string in the string place has already been created for you to experiment with. Use upper method on place and store the result in place up. Okay. Place up equals place dot upper. I think. Place? Dude, I have no idea, man. String dot up. Is it string dot upper? I wish I saw that video again. Oh, wait, can I go back?
And to add my height to the list. Again, the fam list was extended. This is pretty cool because you can write very concise code to update your data structures and summarize use different methods, Python objects, and add methods to your. There are also object time to add string to the object place you on. This means that depending on the type of the object, the methods behave differently. Methods with the same this, as you can see from this error. Objects of different.
Okay, I think I get it. Okay, place. I should just remove this. I don't think there needs to be anything in there. Whatever. Print out place and place up. Print place. Okay, the word place is starting to become meaningless to me. Place up. Run code. Pull out spoilers. Yeah, it changed. Print out the number of O's in place. Print place dot count. I assume 3. Let's get it. Okay, use the object, then you use the method on it. You can use method on objects. This is getting annoying. Strings are not the only Python types that have methods associated with them. This flows integers and booleans are also types that come packaged with a bunch of useful methods. Print out the index of element 20. Print areas dot index 20.0. Does that work? Okay. Print area dot count 9.50. Yay! Nestless methods will change this to the code on. Examples are Pen that adds an element to the list is called on. Pen to remove reverse. Add removes reverses, okay. Simple enough. Use a pen twice. Areas dot append 24.5. Do I just... Can I just do this? I'm sure I can, right? Cool! Takes only one argument. I see why they said use it twice. Areas dot append 15.45. Print out areas. Print areas. Reverse the orders of element near areas. Dot reverse method. Print out areas. Again? Print areas. There we go. Look at this. Packages. Good, another new thing that can break my mind.
By now, I hope you're convinced that Python functions and methods are extremely powerful. You can basically use other people's code to solve your own problems. That's amazing. However, adding all functions and methods that have been written up to now to the same Python distribution would be a mess. There would be tons and tons of code in there that you'll never use. Also, maintaining all of this code would be a real pain. This is where packages come into play. You can think of packages as a directory of Python scripts. Each script is a so-called module. These modules specify functions, methods, and new Python types aimed at solving particular problems. There are thousands of Python packages available from the internet. Among them are packages for data science. There's NumPy to efficiently work with arrays, Matplotlib for data visualization, and scikit-learn for machine learning. Not all of these packages are available in Python by default. To use Python packages, you'll first have to install them on your own system, and then put code in your script to tell Python that you want to use these packages. DataCamp already has all necessary packages installed for you, but if you want to install them on your own system, you can use pip, for example, a package maintenance system for Python. If you go to this URL, you can download the file getpip.py. Next, you go to the terminal and execute python3 getpip.py. Now, you can use pip to actually install a Python package of your choosing. Suppose we want to install the NumPy package, which you'll learn about in the next chapter. You type pip3 install NumPy. You have to use the commands python3 and pip3 here to tell our system that we're working with Python version 3. Now that the package is installed, you can actually start using it in one of your Python scripts. Before you can do this, you should import the package, or a specific module of the package. You can do this with the import statement. To import the entire NumPy package, you can do import NumPy like this. A commonly used function in NumPy is array. It takes a list as input. Simply calling the array function like this will generate an error though. To refer to the array function from the NumPy package, you'll need this. This time it works. The NumPy array is very useful to do data science, but more on that later. Using this NumPy dot prefix all the time can become pretty tiring, so you can also import the package and refer to it with a different name. You can do this by extending your import statement with as, like this. Now, instead of NumPy.array, you'll have to use np.array to use NumPy's array function. There are cases in which you only need one specific function of a package. Python allows you to make this explicit in your code. Suppose that we only want to use the array function from the NumPy package. Instead of writing import NumPy, you can instead write from NumPy import array like this. This time, you can simply call the array function like this. No need to use NumPy dot here. This from import version to use specific parts of a package can be useful, but you're also losing some of the context. Suppose you're working in a long Python script. You import the array function from NumPy at the very top, and way later, you actually use this array function. Somebody else who's reading your code might have forgotten that this array function is a specific NumPy function. It's not clear from the function call. In that respect, the more standard import NumPy as np call is preferred. In this case, your function call is np.array, making it very clear that you're working with NumPy. Off to the exercises now, where you can practice different ways of importing packages and modules yourself.
Great. import package. As a data scientist, some notions of geometry never heard. So first some basics. Fancy clustering, you want the circumference and area of a circle. The radius of circles are, you can calculate C and A as 2 pi r, pi r squared, and use pi. A variable r is already coded in the script. Fill in the code C and A and see how to print. Import math package. Import math. Calculate C. Circumference equals 2 times math dot pi dot times r. calculate A equals math.pi times r exponent 2. Let's get it. I can import things. However you decide to only use part of a package, you can always make your import more selective. Let's say the moon's orbit around the planet is a perfect circle with radius r in kilometers. That is the radians. Oh, how do I do that? Okay, from math import radians. I'm pretty sure it was travel distance over 12 degrees. Store in dist. Dist equals calculate the distance traveled by the moon. You can calculate this r times pi, where r is a reason. Phi is the angle in radians. To convert an angle in degrees. Okay, I'm just gonna do r time should be 12 radians. 12, oh that's degrees, frick. Radians. I assume I just put it in here, maybe? Hopefully. Print out dist. Print distance. Let's get it. Different ways of importing. There are several ways to import packages and modules. Depending on the import call, you'll have to use different Python code. Suppose you want to use the function in INV, which is in Lionel G subpackage of the sci package unit. I'll use this function as follows. Which import statement will you need in order to run the code? What? Well, from this subpackage this, import this as this makes sense. Good job. Functions and packages. Numpy. Isn't that a package? Life. Give me water. Water.
Wow, you've done well, and by now, you're aware that a Python list is pretty powerful. A list can hold any type, and can hold different types at the same time. You can also change, add, and remove elements. This is wonderful, but one feature is missing, a feature that is super important for aspiring data scientists such as yourself. When analyzing data, you'll often want to carry out operations over entire collections of values, and you want to do this fast. With lists, this is a problem. Let's retake the heights of your family and yourself. Suppose you've also asked for everybody's weight. It's not very polite, but everything for science, right? You end up with two lists, height and weight. The first person is 1.73 meters tall and weighs 65.4 kilograms. If you now want to calculate the body mass index for each family member, you hope that this call can work, making the calculations element-wise. Unfortunately, Python throws an error because it has no idea how to do calculations on lists. You could solve this by going through each list element one after the other and calculating the BMI for each person separately, but this is terribly inefficient and exhausting to write. A way more elegant solution is to use NumPy, or numeric Python. It's a Python package that, among others, provides an alternative to the regular Python list, the NumPy array. The NumPy array is pretty similar to the list, but has additional features, such as the ability to perform calculations over entire arrays. It's really easy and super fast as well. The NumPy package is already installed on DataCamp servers, but if you want to work with it on your own system, go to the command line and execute pip3 install NumPy. Next, to actually use NumPy in your Python session, you can import the NumPy package, like this. Let's start with creating a NumPy array. You do this with NumPy's array function. The input is a regular Python list. I'm using array twice here to create NumPy versions of the height and weight lists from before, np height and np weight. Let's try to calculate everybody's BMI with a single call again. This time it worked fine. The calculations were performed element-wise. The first person's BMI was calculated by dividing the first element in MP weight by the square of the first element in MP height. The second person's BMI was calculated with the second height and weight elements, and so on. Let's do a quick comparison of height and weight elements, and so on.
Man,
Let's do a quick comparison of height and weight.
My brain. Oh my goodness. NP underscore. We dividing entire arrays.
Elements, and so on. Let's do a quick comparison here. First, we tried to do calculations with regular lists like this, but this gave us an error because Python doesn't know how to do calculations with lists like we want them to. Next, these regular lists were converted to NumPy arrays. The same operations now work without any problem. NumPy knows how to work with arrays as if they were single values, which is pretty awesome if you ask me. You should still pay attention though. First of all, NumPy can do all of this so easily because it assumes that your NumPy array can only contain values of a single type. It's either an array of floats, an array of booleans, or something else. If you do try to create an array with different types, like this for example, the resulting NumPy array will contain a single type, string in this case. The booleans and the floats were both converted to strings. Second, you should know that a NumPy array is simply a new kind of Python type, like the float, string, and list types from before. This means that it comes with its own methods, which can behave differently than you'd expect. Take this Python list and this NumPy array, for example. If you do Python list plus Python list, the list elements are pasted together, generating a list with 6 elements. If you do this with the NumPy arrays, on the other hand, Python will do an element-wise sum of the arrays. Just make sure to pay attention when you're juggling around with different Python types, because the outcomes can differ a lot. Apart from these subtleties, you can work with NumPy arrays pretty much the same as you can with regular Python lists. When you want to get elements from your array, for example, you can use square brackets. Suppose you want to get the BMI for the second person, so at index 1. This will do the trick. Specifically for NumPy, there's also another way to do list subsetting, using an array of booleans. Say you want to get all BMI values in the BMI array that are over 23. A first step is using the greater than sign, like this. The result is a NumPy array, containing booleans. True if the corresponding BMI is above 23, false if it's below. Next, you can use this boolean array inside square brackets to do the subsetting. Only the elements in BMI that are above 23, so for which the corresponding boolean value is true, is selected. There's only one BMI that's above 23, so we end up with a NumPy array with a single value. That.
Are you kidding me, man?
Specific BMI. Using the result of a comparison to make a selection of your data is a very common way to get surprising insights. Learn all about it and the other NumPy basics in the exercises.
This is cruel. This is too cruel. Okay. Power through. In this chapter, we're going to dive into the world of baseball. Along the way, you'll get comfortable with the basics of NumPy. Do data for this. Baseball has already been defined in the Python script, representing the height of some baseball players in centimeters. Can you add some code here and there to create a NumPy array from it? Import NumPy as np, create a NumPy array from the baseball. np.array baseball np underscore base printer dot np. What? Something's not right. Did I do something? Wait, maybe I used the np.array wrong? np. Take on import baseball. Yeah, I inputted baseball. Assign the result of the function call to np underscore baseball to print out the print. Oh, it said time! It said time! No way, man! No way! I'm not dumb. I swear I'm not dumb. I swear I'm not dumb. Oh my goodness! What was its type? It's a class numpy array. Cool. Baseball's height. You're a huge baseball fan. You decide to call Major League Baseball and ask around for some statistics on the height of main players. Pass along data on more than 1,000 players, which is stored as regular Python list. Height underscore in. The height is expressed in inches. Can you make numpy array out of n completely use the meters? Height is already relevant. Let's start this one at a time. np underscore height underscore height in equals np dot array. Alright. To meters. Oh, I can't, I guess. Multiply by 0.0254. And pi underscore height underscore m. Cool. Print np. Okay. It's gonna really break my mind when I go back to Java. Frick. It'll be let's wait. Again, both are available as regular Python. There's height underscore in and weight underscore pounds. Jeez, please use the metric system. It's now possible to calculate BMI of each baseball player. Python code to convert height into a numpy array with the correct units so development work and follow the instructions step by step. Create a numpy array for pounds to the metric. Okay, np underscore weight underscore kilogram equal weight. Alright, create an array. So np dot array weight lb dot this series of numbers, calculate the BMI BMI equals weight over height squared. I did not know that. It's good to know. Print BMI. Let's go. Let's go. To subset both regular Python list and number, you can use square brackets. For numpies. You can use Boolean numpy arrays to code that kind of thing is already good. Follow instructions or interesting things from the data. This is getting confusing. The element of the array should be create a Boolean numpy array. Okay. Okay, that's the BMI has already been calculated. Wait, they're already arrays. So BMI below 21 is light. Okay, print light. No, light for Death Note. Print out numpy arrays or those below. Okay. Print. BMI bracket square bracket light. I think. Yes. Let's get it. Accessing it requires square brackets for both lists and arrays. As Hugo explained, NumPy is great for doing vector arithmetic. If you compared its functionality with regular Python, this how some things have changed. First of all, NumPy arrays cannot contain elements of different types. If you try to build such others, some of the element types are changed up to end with the homogeneous lists known as type coercion. What are you saying? What's changed? NumPy arrays cannot contain elements with different types. That is true. If you try to build such a list, some of the element types will change to end up with homogeneous lists. Yes, that is also true. Second, the typical arithmetic operators such as have different meaning for regular Python lists and NumPy arrays. Have a look at this line of code. NP data array. Can you tell which code chunk builds the exact same Python object? The NumPy package is already imported as NP, so you can explain. Huh? Okay, this is kind of breaking my mind. So let's try to solve this by using logic instead of typing it into the Python shell because I want to be smart. So when you add numbers together in arrays, they add directly. So it'd be, they would be turned homogeneous, which means with the booleans, what would booleans be when they turn into, like, ones and zeros is my assumption. Okay, can you tell which code chunk builds the exact same Python object? My assumption is correct. Probably not these ones because they add directly, so it's either of these two. 1 and -1 is reasonable, so I'm gonna go for this. Bow! What is it? I'm just gonna put this in the Python shell. I give 452. Why is that? Oh, it is 1 and 0. Oh, I'm an idiot. Which means the conclusion is, so like our addition, you can switch around the values. I'm so stupid. Yeah, 1s and 0s. 1 is true, 0 is false. Machine with your analyzed Python lists NumPy arrays sometimes behave differently. Luckily, there are still some T's in the world. Thank you for this example of subsetting. Using the square bracket notation on this works exactly the same. To see this for yourself, try. Oh, I did it before. Okay, subset. Okay, print. NP weight at the index 50 and print out a subarray. Of NP height. I assume 100 up to 1. Let's get it. It works. Even though it's array, you can do the little bracket trick. 2D NumPy arrays. Cool. 2D NumPy arrays. Kinda what Mac is. Really what Mac is. Alright.
Well done, you legend. Let's now recreate the NumPy arrays from the previous
legend.
video. If you ask for the type of these arrays, Python tells you that they are numpy.ndarray. NumPy tells you that it's a type that was defined in the NumPy package. NDArray stands for n-dimensional array. The arrays NP height and NP weight are one-dimensional arrays, but it's perfectly possible to create two-dimensional, three-dimensional, heck, even seven-dimensional arrays. Let's stick to 2 in this video though. You can create a 2D NumPy array from a regular Python list of lists. Let's try to create one NumPy array for all height and weight data of your family, like this. If you print out NP2D now, you'll see that is a regular data structure. Each sublist in the list corresponds to a row in the two-dimensional NumPy array. From NP2D.shape, you can see that we indeed have 2 rows and 5 columns. Shape is a so-called attribute of the NP2D array that can give you more information about what the data structure looks like. Note that the syntax for accessing an attribute looks a bit like calling a method, but they are not the same. Remember that methods have round brackets after them, and you can see here that attributes do not. Also, for 2D arrays, the NumPy rule applies. An array can only contain a single type. If you change one float to be a string, all the array elements will be coerced to strings to end up with a homogeneous array. You can think of the 2D NumPy arrays as an improved list of lists. You can perform calculations on the arrays, as I showed before, and you can do more advanced ways of subsetting. Suppose you want the first row, and then the third element in that row. To select the row, you need the index 0 in square brackets. Don't forget about zero indexing. To then select the third element, you can extend the same call with another pair of brackets, this time with the index 2, like this. Basically, you're selecting the row, and then from that row, do another selection. There's also an alternative way of subsetting, using single square brackets and a comma. This call returns the exact same value as before. The value before the comma specifies the row. The value after the comma specifies the column. The intersection of the rows and columns you specified are returned. Once you get used to it, this syntax is more intuitive and opens up more possibilities. Suppose you want to select the height and weight of the second and third family member. You want both rows, so you put in a colon before the comma. You only want the second and third column, so you put in the indices 1 to 3 after the comma. Remember that the third index is not included here. The intersection gives us a 2D array with 2 rows and 2 columns. Similarly, you can select the weight of all family members like this. You only want the second row, so put 1 before the comma. You want all columns, so you use a colon after the comma. The intersection gives us the entire second row.
My brain can't take this anymore. I'm gonna go for a break. Going for a break. Screw this. to suffering.
Well done, you legend. Let's now recreate the NumPy arrays from the previous video. If you ask for the type of these arrays, Python tells you that they are numpy.ndArray. NumPy tells you that it's a type that was defined in the NumPy package. NDArray stands for n-dimensional array. The arrays NP height and NP weight are one-dimensional arrays, but it's perfectly possible to create two-dimensional, three-dimensional, heck, even seven-dimensional arrays. Let's stick to two in this video though. You can create a 2D NumPy array from a regular Python list of lists. Let's try to create one NumPy array for all height and weight data of your family, like this. If you print out NP2D now, you'll see that is a regular data structure. Each sublist in the list corresponds to a row in the two-dimensional NumPy array. From np2d.shape, you can see that we indeed have 2 rows and 5 columns. Shape is a so-called attribute of the np2d array that can give you more information about what the data structure looks like. Note that the syntax for accessing an attribute looks a bit like calling a method, but they are not the same. Remember that methods have round brackets after them, and you can see here that attributes do not. Also, for 2D arrays, the NumPy rule applies. An array can only contain a single type. If you change one float to be a string, all the array elements will be coerced to strings to end up with a homogeneous array. You can think of the 2D NumPy arrays as an improved list of lists. You can perform calculations on the arrays, as I showed before, and you can do more advanced ways of subsetting. Suppose you want the first row, and then the third element in that row. To select the row, you need the index 0 in square brackets. Don't forget about zero indexing. To then select the third element, you can extend the same call with another pair of brackets, this time with the index 2, like this. Basically, you're selecting the row, and then from that row, do another selection. There's also an alternative way of subsetting, using single square brackets and a comma. This call returns the exact same value as before. The value before the comma specifies the row. The value after the comma specifies the column. The intersection of the rows and columns you specified are returned. Once you get used to it, this syntax is more intuitive and opens up more possibilities. Suppose you want to select the height and weight of the second and third family member. You want both rows, so you put in a colon before the comma. You only want the second and third column, so you put in the indices 1 to 3 after the comma. Remember that the third index is not included here. The intersection gives us a 2D array with 2 rows and 2 columns. Similarly, you can select the weight of all family members like this. You only want the second row, so put 1 before the comma. You want all columns, so you use a colon after the comma. The intersection gives us the entire second row. Finally, 2D NumPy arrays enable you to do element-wise calculations, the same way you did with 1D NumPy arrays. That's something you can experiment with in the exercises, along with NumPy arrays. That's something you can experiment with in the exercises, along with creating.
For 2D NumPy array from baseball. You want screw typing equals np dot array print out the shape. Oh, I didn't do print, that wasted my time. Print out the type. I didn't do the type. So stupid. Non-sus mode. Print out the type of. It's an nth-dimensional array. N-dimensional array. Have another look at the Major League Baseball data and realize that it makes more sense to restructure all this information in a 2D NumPy array. This array should have that's a lot of rows, corresponding to that's a lot of players you have information on, and 2 columns for weight and height. A Python list of lists. In this list of lists, each sub-list represents the height and weight of a single baseball player. The name of the embedded list is baseball. Can you store the data as 2D array to unlock NumPy's extra functionality? Well, yes, I can, fine gentlemen. Equals np dot array. I think it's just the regular array baseball. Print out the shape of. I'm pretty sure I did something wrong. Nah, I did it right. It was very simple. Simple task. If your 2D NumPy array has a regular structure, each row and column has a fixed number of values. Complicated ways of subsetting become very easy. Have a look at the code below where elements A and C are extracted from a list of lists. Alright. A is yes and C is also yes. Which is that I'm reading this. NumPy import NumPy as np underscore x equals NumPy senpy. That is also alright around it. For regular Python, this is a real pain. For 2D NumPy arrays, where it's pretty intuitive. The indexes before. The indexes before the comma refers to rows, while those after the comma refers to the columns. The is for slicing. In this example, it tells Python to include all rows. There's code that converts baseball list to is there? Print the 50th row of compute underscore baseball 50. Select the entire second column. Okay. Equals this bracket colon no. So yes, colon 1. Print out the height. Print. The height should be 124.0. No! I actually made that mistake. Are you kidding me? I'm so stupid. Bakayero. That's so cringe. Okay, remember how you calculated the body mass index for all players? NumPy was able to perform all calculations element-wise, element by element for 2D NumPy array. This isn't any different. You can combine matrices with single numbers of vectors and result. Execute the code below in the Python to see if you understand. My throat is getting dry. This is painful. Up to the next video, I'm gonna freaking stop. I can't do this anymore. My brain is too small. Okay, print out the addition. Okay. 3 column. Timed out addition. Right. Managed to get a hold of changes. It is available as a updated add. I don't get it. Let's just see if I understand. Okay. Let's we print out something. So, oops. Print bracket M. Okay, update is a 2D numpy array plus updated should mean something. Create a numpy array conversion. Conversion equals np dot array with values. Oopsies. With values of the thing that makes it meters, and then the thing that makes it kilograms, and then the thing that makes it not change, because age is universal. Print out the product of the NP baseball, and then converting it to Australia. I mean, UK, sort of. Just, I can use the metric system already. Yo, quitting time, I'm quitting. Next video. Not this time, baby. See ya.